Salam and welcome everyone. So today we're going to be working on the question on the screen that says iron is heated from 100 degrees Celsius to 150 degrees Celsius. By how much does its chemical potential change? Take the standard molar entropy to equal 53 joule per mole Kelvin for the entire range. So the first thing you have to do is this. We have to write out the parameters because we are chemists. So we have the initial temperature, which is what we're given to be 100 degrees Celsius. We know our final temperature to be 150 degrees Celsius. We also know in chemistry that we don't just leave our work in simply degrees Celsius. We always change our temperature to Kelvin. So you have T1 is equal to 100 degrees Celsius, which of course you can see plus 273.15, and then here as well 273.15. So you end up here having this here to be 373.15 Kelvin for the T initial, and the T final is just going to be 420 3.15 Kelvin. So that's that. Then we were told by how much does its chemical potential change. So what this is just asking us is what is the change in chemical potential over time for this particular process where iron is heated from 100 degrees Celsius to 150 degrees Celsius. So basically what this is just telling us is that we're supposed to find the change in chemical potential because it was what they're asking, by how much does the chemical potential change. Then we're told the molar um, entropy is just simply, or the standard molar entropy is just simply 53 joule per mole Kelvin for the entire range. So, of course, the entire range for temperature. So, the next thing we have to do is to write out the formula for finding molar entropy at constant pressure whenever there's a temperature change. So, you have change in U is actually going to equal negative minus molar entropy, okay, times change in temperature. So this is actually the formula to solve questions like this where you're finding the change in where you're finding the change in chemical potential over time at constant pressure when there is a change in temperature. So you have change in chemical potential becomes minus, you have this here, so minus 53 joule per mole Kelvin times change in temperature, which is just T final minus T initial. So that would be 423.15 Kelvin minus 373.15 Kelvin. So this is T final here minus T initial. So you have the change in chemical potential, which will be negative 53 joule per mole Kelvin times 423 minus 373 is just simply 50.00 Kelvin. So you cancel out the Kelvin, cancel out the Kelvin. So change in chemical potential is just negative 53 times 50, which is just simply negative 2650 joule per mole. So this is basically the answer to this question. So I wanted to also mention that yeah, this is the answer to this question. This is what you put it as. If you're told to put in a specific number of significant figures, maybe you were told to put in two sig figs, in three sig figs. If you were told to put this answer in, for example, two sig figs, you end up with negative 2.7 times 10 raised to the power of 3 joule per mole Kelvin, or negative 2.7 kilojoule per mole. So also make sure you pay attention to the proper number of significant figures that you're supposed to put this answer in. I wanted to say that this is just one question from the multiple questions on my playlist for physical chemistry, where I go through the thermodynamics portion of the Atkins Physical Chemistry 11th edition textbook. So make sure if you have that textbook, you should watch all my videos for you to get the full grasp and for you to succeed in your class, right? For you to succeed in your course. I also want to mention that if you're a student struggling in any of your STEM related courses, whether you're in middle school, high school, or college, I am the tutor for you. I help students succeed in all their STEM related courses and to be the best version of themselves in academia. So if you would like to book an appointment or if you would like a tutoring package that would be ongoing, make sure you email me at shuhabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.